In our observable universe, everything has a limit. Just for example, human has an age limit, freezing and boiling temperature has a limit, and global warming is the result of exceeding the temperature limit. Even when we get angry, we usually say, "Don't dare to cross the limit." But if someone or something crosses the limit, the normal rule becomes invalid. After crossing every limit, a new rule is generated. Just for example, after crossing the freezing temperature limit, water becomes ice. And the ice is very different from water. Do you know about Kohinoor diamond? I think it doesn't need any explanation. Diamond is a form of carbon, but very different from other forms of carbon. Just because during its formation, it crosses a certain temperature and pressure limit. So after crossing a certain limit, everything changes drastically. These changes can be so massive that it can give birth to the unknown. In the same way, when the mass of an object passes a certain limit, it breaks the Newton's law. The school-level physics book can't help you to understand such an object. This is the object where enormous speed of light starts feeling tiny. It's the black hole, the world of extreme. Till now, many concepts about black hole are very debatable, though the existence of black hole has been confirmed with this image, captured on 24th March 2021. Today, in this video, we will learn about the black hole, the world where Newtonian physics fails. So I highly request you to close your school-level physics book and stay with me till the end of this video. I hope at the end of this video, I'll earn your like and subscription. Hello everyone, my name is Aditya and welcome back to my YouTube channel, Skyman. Before diving into the topic, let's try to understand what black hole is and why is it black. Black is not a color. When there is no light coming out from something, it appears black. This means black hole doesn't emit or reflect any light in any spectrum. That's why it appears black. But why? Let's try to understand it with a simple example. Everything in our universe that has mass also has gravity. In the case of our Earth, if we want to go away from Earth against its gravity, then we have to achieve a minimum speed of 11.2 km per second, which is called escape velocity. If you throw something and do not want it to come back to you, then it will be needing the minimum speed of 11.2 km per second. Similarly, the sun's escape velocity is 617.6 km per second, which is much higher than Earth due to its high mass and high gravity. The escape velocity increases with the increasing mass and gravity of an object. For black hole, the escape velocity is higher than the speed of light. An object needs more than the speed of light to escape the black hole. Technically, in our universe, nothing can exceed the speed of light, so nothing comes out from a black hole, not even light, and it appears black to us. We all know the speed of light is a constant and it travels in a straight line. But how can gravity influence the light? How can the gravity of a black hole bend the light which is trying to come out from it? There must be something wrong. There must be something that is not constant, but we usually consider it as a constant. This is the situation where Newtonian physics fails. In this particular situation, great scientist Sir Albert Einstein came up with a new solution named the theory of relativity. He said time is variable with respect to mass. According to him, whole universe is placed on an imaginary space-time fabric, where every object placed on it creates a bend downward due to its gravity. As the mass increases, the curvature of the bend increases, and the flow of time slows down for the object. In simple words, with the increasing mass, the time starts flowing slowly. In the film Interstellar, it was shown with a great accuracy. According to the film, when Cooper and his friends land on a planet, their 1 hour was equivalent to 7 years on Earth. It happened because the planet was near to the gargantua black hole. With the same logic, when the mass of an object reaches infinity, then the time stops for the object. So in the center of a black hole, the mass reaches almost infinity and the time almost stops there. It's called singularity. Why almost? Because no one knows what happens there, and a big debate is ongoing on this topic among scientists. I know it's little tough to understand because we know time as a constant entity. If you think this concept is tough to digest, then you are not uncommon. Even Sir Albert Einstein didn't believe in the existence of black hole. He thought this extreme is only possible on pen and paper, not in reality. It's very sad that he died before the discovery of a black hole. Now, I think you have got a small idea about a black hole. The first discovered black hole is Cygnus X1. In the year 1964, in the constellation of Cygnus, scientists observed a strong X-ray source which is 7,000 to 7,500 light years away from us. Around 1970s, it gained popularity due to the debate between Stephen Hawking and his friend Kip Thorne, where Kip Thorne said it's a black hole and Stephen Hawking said it's not. Later, Stephen Hawking lost the bet, making Cygnus X1 the first discovered black hole by humanity. This kind of black hole generally forms from the death of a star, supernova. When a star more massive than 40 to 50 solar mass goes through the supernova process, it creates a black hole as a supernova remnant. This kind of black hole is called stellar mass black hole. For better understanding, you can see this video where I talked about supernova in detail. Back to our topic. The Cygnus X1 is a black hole with the mass of approximately 21.2 solar mass, and its radius is almost 300 km. Just think the gravity of an object, mass equivalent to 21 to 22 Sun, and packed it within a sphere of 300 km radius. That's how dense black holes generally are. I know it's beyond imagination. This black hole is originally a part of a binary system. The companion is a star of mass 20 to 40 solar mass. Both objects orbit each other from a distance of 20% of Earth-Sun distance. Due to this small distance, the black hole is stealing gas and material from the star and emitting X-ray. When something comes closer to a black hole, its enormous gravity attracts the matter. This can be star, planet, or anything. This matter starts revolving around the black hole. It's called the accretion disk. The speed of the accretion disk can be as high as 40 to 80% of speed of light. This speed and friction in between particles emits a huge amount of light, especially in X-ray spectrum. A black hole doesn't emit any light in any spectrum, but the accretion disk is visible from millions to billions of light years. That's why we detected the X-ray source from this system. The first image of black hole was published on 24th March 2021. It was the supermassive black hole at the center of the galaxy Messier 87. Almost every galaxy has a black hole at its center. We have also captured the supermassive black hole at the center of our Milky Way galaxy, the Sagittarius A star. Our supermassive black hole is tiny when we compare it with Messier 87 black hole. For example, the mass of Sagittarius A star is 4.297 million solar mass, which is totally mind-boggling. But the Messier 87 black hole is almost 1,500 times more massive than Sagittarius A star. For reference, you can see the comparison between the Sagittarius A star and Sun-Mercury orbit. On the other hand, the Messier 87 black hole and Pluto's orbit. Still, we are not near to the most gigantic one, TON 618. Before knowing about the mass, just see the size comparison between Messier 87 black hole and TON 618. If this is the orbit of Neptune, then this is the size of TON 618, and this is the distance of Proxima Centauri from the Sun. I know it's very tough to realize. Now the mass of TON 618. It's almost 66 billion solar mass, means 66 billion times more massive than our Sun, and almost 15,000 times heavier than our Milky Way supermassive black hole, Sagittarius A star. In this picture, this star is an ordinary star in our Milky Way, a couple of thousand years away. And this one is TON 618, almost 10.8 billion light years away. For reference, our Milky Way is spread across only 0.1 million light year, and TON 618 is almost 10.8 billion light years away. If you are still not getting the idea, then our observable universe is of 13.8 billion light years. So it's almost at the edge of our observable universe. And the light which we are seeing has traveled double the age of our solar system. Due to this black hole's extreme high luminosity, scientists miscalculated it as a Milky Way star. Later, when astronomers recalculated the redshift of this light source, they reclassified it as a quasar. Now, what is a quasar? Quasar is an active black hole. When a supermassive black hole at the center of a galaxy eats up a huge amount of gas and matter, its accretion disk takes a gigantic size. As the matter rotates with the accretion disk and reaches near to the black hole with 40 to 80% of speed of light, the friction in between particles increases drastically. It releases a huge amount of light, which is spatially visible in X-ray spectrum. This luminosity can be as high that it can be easily misjudged as a nearby star. But it is originally located at the edge of our universe. These kind of massive quasars are generally found at the edge of our universe, though the cause behind it is still unknown. Besides this, the existence of these giants in the early age of our universe is also a mystery. Usually, every galaxy has a black hole at the center of it. According to our observation, elliptical galaxy contains more massive black hole than spiral galaxy. For example, the galaxy Messier 87 is an elliptical galaxy, and our galaxy Milky Way is a spiral galaxy. So the Messier 87 black hole is way bigger than our Sagittarius A star. Every galaxy contains thousands to millions of stellar mass black holes, but it generally has one supermassive black hole at the center. Scientists think there may be as many as 100 million in our galaxy alone. One galaxy in our neighborhood is very different, the Triangulum galaxy. It's the satellite galaxy of Andromeda galaxy. I think you all know about the Andromeda galaxy. If you want to know more about Andromeda galaxy in detail, please write it down in the comment section. I'll make a separate video on this topic. Back to Triangulum galaxy. According to observation, it doesn't have a supermassive black hole at the center, which is very odd. The study is still ongoing on this topic. The nearest black hole is BH1. It's almost 1560 light years away from us. During the survey of the sky, the Gaia telescope from European Space Organization discovered it. It also discovered BH2 and BH3, making BH3 the largest stellar mass black hole in our galaxy. We only can discover a black hole if and only if there is something interacting with the black hole. All the discovered black holes were either discovered by an orbiting star or by an interacting gas cloud or by a modern technique predicted by Sir Albert Einstein, gravitational lensing. It's really tough to identify a lonely black hole as it doesn't emit any light in any spectrum. So we are completely unaware of a potential threat by a lonely black hole. If a black hole is coming towards us, then it will be very late when we will realize that. The destruction by black hole doesn't end here. When two black holes collide, it creates the gravitational wave. It's the silent killer on universal scale. This wave spreads out with a speed equivalent to light. We can detect the gravitational wave from Earth by Laser Interferometer Gravitational Wave Observatory, LIGO. Thankfully, the gravitational wave that reaches Earth is not strong enough for any destruction. LIGO released a gravitational wave originated from a merger of two black holes in sound form. Listen carefully. After detecting the wave, scientists do the back calculation and find the original mass of two parent black holes and the resultant black hole. For example, in this case, two black holes collided with the mass of 85 and 66 solar mass and formed a black hole of 142 solar mass. But as per our knowledge, 85 plus 66 is equal to 151. So why 142 solar mass? According to the famous mass energy equation by Sir Albert Einstein, mass and energy are interchangeable in some extreme conditions. E equal to mc square, where E is energy, m is mass and c is the speed of light. So in the case of two black hole merger, a huge amount of mass gets converted into energy and creates a big explosion. That's why we have found the mass of the black hole as 142 solar mass, almost 9 solar mass less than the calculated mass 151. This means within milliseconds, the mass equivalent to 9 times of our Sun got converted into energy. Just unimaginable. This destruction can take a massive form if it happens with two supermassive black holes with millions to billions of solar masses. However, scientists think It's not possible due to a theoretical problem called the final parsec problem. We still don't know much about it. So, that's it. The black hole, the invisible giants, the resultant of extreme curvature of space-time. Till today, our understanding about black hole is very limited. We still don't know what happens inside a black hole. Is there any way to come out from a black hole? Is there any similarity between Big Bang and the black hole? There are many questions that doesn't have any answer till today. Still, if you have any specific question about this topic, please don't hesitate to write it down in the comment section. I would love to know your thoughts. If you have found this cosmic journey as fascinating as I did, please give this video a thumbs up, share it with your friends and family members, and subscribe for more space-related content. And remember, keep looking up, stay curious, and explore the mysteries of the night sky.